Hello class, my name is Connor Hans, and welcome to my presentation on NextGen, revolutionizing air traffic control for the future. To start off, the air traffic control system is designed to keep aircraft moving safely and efficiently throughout the national airspace system. Air traffic controllers rely on a combination of surveillance, communication, and coordination to separate aircraft and manage traffic flow. As air traffic has continued to increase over time, the older air traffic control system began to show its limitations, especially when it comes to capacity and efficiency. Because of these challenges, the FAA introduced NextGen as a way to modernize how air traffic is managed. The two core components of air traffic control are surveillance and communications. Surveillance allows controllers to know where aircraft are in terms of position and altitude, which was traditionally done using radar systems. Communications allow controllers and pilots to exchange clearances and instructions, mainly through voice radio transmissions. During busy periods, these systems can become congested, increasing workload and potential for errors. This is why improvements in these areas are so important for safety. NextGen improves these same ATC functions by introducing newer technologies. One major component is ADS-B, which uses satellite-based position reporting and provides more accurate tracking than radar. Another key component is data communications, which allows clearances and instructions to be sent digitally instead of relying only on voice communication. These upgrades help reduce radio congestion and miscommunication while making ATC operations more precise and predictable. One of the most important parts of NextGen is SWIM, or System-Wide Information Management. SWIM acts as the backbone of the system by allowing data like weather information, flight plans, and surveillance data to be shared across the entire airspace system in real time. This shared information helps air traffic controllers, airlines, and traffic managers make better decisions and improves coordination across the airspace system, especially during high traffic or complex situations. One major advantage of GPS and satellite-based navigation is the reduction in pilot workload. Instead of constantly using tools like an E6B flight computer or manually updating your position on a sectional chart, GPS provides accurate real-time position information. This allows pilots to focus more on situational awareness and control of the aircraft. GPS also supports performance-based navigation, which allows aircraft to fly more precise and repeatable routes, making traffic easier for air traffic controllers to plan and manage. An example of operational planning improvement under NextGen is time-based flow management, or TBFM. This system helps controllers manage traffic by sequencing aircraft based on time rather than just distance. TBFM allows for better planning of arrivals, especially during periods of heavy traffic, and helps reduce congestion and controller workload. Overall, it supports more efficient and predictable traffic flow into busier airports and airspaces. Wrapping things up, air traffic control is still based on the same core functions of surveillance and communication, but NextGen modernizes how these functions are performed. Systems like ADS-B, data communications, and SWIM improve accuracy, information sharing, and predictability across the airspace. GPS navigation also reduces pilot workload while helping ATC plan traffic more effectively. Overall, NextGen represents a move towards a more proactive and data-driven approach to air traffic management, which is important for maintaining safety as air traffic continues to grow. This concludes my presentation. Thank you very much for listening and have a great day.